So now on this set of questions, we're just solving some exponential or logarithmic equations. And whenever you solve an exponential equation, what you're going to do is turn it into a logarithm. And if you're going to solve a logarithmic equation, you're going to turn it into an exponential. Why? Because they're inverses of each other. Okay, on number 17, we have 216 to the x plus 5 is equal to 1 over 36 to the 2x plus 3. They have different bases. But they can be rewritten as the same base. They're powers of 6. So, for example, 216 is 6 to the third. And to get 36, it's squared, but if I need the fraction, if I want 1 over 36, this is going to be 6 to the negative 2 power. Okay, so now write these with the original exponents. X plus 5 equals, and then 2x plus 3. So remember, whenever you're rewriting these bases, that the original number and your new number should be exactly the same. What some people are trying to do is make one of these things equal to the other one, and you don't do that. You want the bases the same, but the original number, 216, should still be the same number, 216, which is 6 to the third. Now, since the bases are the same, we can equate the exponents, making sure that we distribute here. So 3 times x plus 5 should be equal to negative 2 times x plus 3. That's a plus sign. Alright, so distributing on the left side, I get 3x plus 15. Distribute on the right side, negative 2x minus 6. Oh, whoops, this was a 2, which means this is actually not a 2, that is a 4. Okay, that's better. And now just get the x's on one side, so I'm going to add these over here, and I get 7x. Subtract the 15 over equals a negative 21. Divide by 7, x is equal to negative 3. That turned out to be nice and neat. Okay, and you know, it's not a bad idea to just stick this back into the original equation to test it out. I'll leave that up to you. Alright, number 18. Number 18, some people, what they did is just simply rewrite this in logarithmic form. So rewriting in logarithmic form, the base is going to be 3, and our answer, this is the exponent right there. That is not true. Here, whoops. The exponent is the answer, so x is equal to the log base 3 of pi. So you can't put log base 3 of pi into your calculator because you have a base 3 and you need to change the base. So another way to work this, if you don't remember the change of base formula, because some people got this mixed up, they had the wrong thing on the bottom. So it's always base goes on the bottom. So if you were going to, what happened to that? Use the change of base formula, you'd go log of what you're taking the log of, and that can be common log or that can be the natural log, pi divided by the log of 3. Like I said, what some people did wrong on this is that they switched it. They put the log of 3 on the top and the log of pi on the bottom, but the base goes on the bottom. Okay, alternatively, you could just take the original problem and just take your favorite log of both sides. I like the natural log. On the left-hand side, I have an exponent, and using the power property, that gets to come out front to multiply times the natural log of 3 equals the natural log of pi. And now, just divide by the natural log of 3, so x is equal to the natural log of pi divided by the natural log of 3. The reason why I like this method is because it changes the base for you. You don't have to memorize any kind of change of base formula. So now at this point, putting it into the calculator and rounding it off, we get about 1.04. So there we go.